Hello everyone, this is Shah Mohammad Hasibuddin and my team members are Vikas Meneni, Bhusa Nikhil and Tejashwa Reddy. The title of our project is Smart Cultivation System using IoT. We have done this project under the guidance of Mrs. Apurva Khandekar ma'am, Assistant Professor at GRIT. This is the abstract of our project. The primary target of our project is to help farmers in acquiring live data for effective environmental monitoring, including soil moisture, temperature, humidity, and state of the soil, and also automating the watering process accordingly, which allows them to boost product quality and overall yield of the crop. The smart soil monitoring system proposed through this project is integrated with IoT technology, mixed with different sensors, and it includes designing a sensor network. The live data feed can be obtained through help of mobile app. An Android mobile application is developed, and the user can obtain the values using that mobile application. This is the algorithm of our project. The first algorithm includes the connecting of the sensors. Select the following sensors: DHT11, motor pump, ESP82, soil moisture sensor and relay module. Connect the soil moisture sensor to the soil to determine the soil moisture content. Connect the DHT11 to determine the soil's temperature and humidity. Connect the motor pump to the IoT sensor network. Connect the relay module function, which is mainly used to switch the electrical devices and system on or off. Determine how often to take the sensor reading based on the project needs. Write a code to read the sensor values and store them as variables. Use the sensor values to make decisions about the crop cultivation, such as when to water the plants and how to adjust according to the environment. Continuously monitor and evaluate the sensor performance to improve accuracy and reliability. This is the second algorithm of our project, which includes implementation of the code and creating of the mobile app. Connect the ESP82 board module to the necessary sensor using a port. Write the code in Arduino IDE software to read the sensor data and send it to the ESP82 board. Compile the code and upload it to ESP82 board. Create an Android mobile application to display the mobile sensors values and state of the soil to the end users. Connect the Android mobile application to the ThinkSpeak real-time database. Store the sensor detected values in the real-time database. Display the stored data from the database in the mobile application through the help of internet. Allow users to read the sensor data through the help of mobile application. This is the implementation of the code. This is the code, and this is mobile app creation, which includes the App Inventor Designer, App Inventor Block Editor, Android Emulator, and an Android phone. The app inventor used here is MIT. MIT is a predefined app inventor to create the mobile app. MIT App Inventor is a visual programming environment that allows everyone, even children, to build fully functional apps for smartphones and tablets. This is the setup of our project. Here is the motor, and here is all the sensors, and this is the soil, and the soil moisture sensor is placed inside the soil, and all the sensors are connected. This is the final result of our project, which will be displayed on mobile application. So here there are two situations. In the first one, when the soil is wet, these are the values which will be displayed on the mobile app. If the soil is wet, the motor will not rotate, which means that the soil does not need any water. When the soil is dry, these are the values which will be displayed on the mobile app. When the soil is dry, the motor will rotate, which indicates that the rotating of the motor indicates that the water is being pumped and the water is being given to the soil. So this is the conclusion in the further scope. The Smart Cultivation System project has successfully achieved its objectives by accurately monitoring soil moisture levels and soil state using sensor and monitoring temperature and humidity using DHT11 sensor and automating the watering process accordingly. It includes designing a sensor network, creating a user-friendly interface by integrating an automated watering mechanism. It provides an efficient solution for water management, promoting optimal plant growth while conserving resources. The system contributes to sustainable practices in agriculture and gardening, enabling effective soil moisture monitoring and water conservation. The system may also incorporate data logging, real-time notification, and remote access features in the future. Thank you.